2 nitrate plus potassium iodide. What's the charge on my lead? 2. So if my lead is 2, my I, if my I is 1, PbI2 plus KNO3 so now that you've got your two products, you go back to your solubility table and see what their solubilities are. So PbI2 and KNO3. So what's the subscript on the easy one? Nitrate. What's the subscript? AQ, absolutely. Because all nitrates are soluble. How about the lead iodide? Kyle? Eden, what do you think? Lead 2 iodide. Okay. Brianna? S. Jacob?
S.
Wow, you did that. Your lips didn't move, yet your voice came out over there. Ventriloquism. S. I don't know where. Here. Here we go. Iodide. This column right here. There you go. Lead 2 plus. There it is right there on the bottom. So it's a solid. So is this a double displacement reaction? Yes, it is, because our products are not AQ. Or rather, not both AQ. So you're switching the metals when you do a double displacement. But you've also got to make sure your formula for your products are correct. So I've got iron 3 and sulfate, which is 2 minus. So you make iron 3 sulfate plus sodium chloride. So now you've got to balance it. Okay, sodium chloride.
How do you get that?
How do I get
Like the answer?
the compounds, what they are? You take the metals and you've got to switch their places. Okay? You switch the first part in both, but you don't necessarily have the same subscripts. It depends. You've got to do your new cross and drop. Okay? So, sodium chloride, solid or AQ? AQ. How about iron 3 sulfate? It's AQ. So this actually would be a no reaction. you would not actually see any change. For the first reaction, you're actually going to see a solid form where you had two liquids. This one, you've just got the same ions floating around. You got iron 3+, chloride, sodium, and sulfate, all just floating around.
When you have like double displacement, you don't need to do electronegativities, do you?
Nope. Just single displacement. So you see no visible change. There's no gas. We don't have an acid or a base, so there's no pH change. There's no precipitate, so it's an NR. We don't see a visible change.
So it's NR because the Na is lower electronegativity?
No, it has nothing to do with electronegativity.
That's why.
That's it, both AQ. So that means they're both dissolved. So you just still see the same colors. If they're both clear and colorless, it would stay clear and colorless. Iron tends to be yellow. Iron 3+ tends to make yellow solutions. It's just going to stay yellow. Okay? Just means you've got these ions floating around. So what happens? What does sodium chloride look like? Salt. What does it look like? If you were going to describe it to somebody, it's white. It's hard. Crystals. So if you have a pile of sodium chloride, you actually see, you actually see a pile of white solid. If you dissolve that white solid in some water, it disappears. It might be a little bit cloudy to start with, but as you stir it, that cloudiness disappears. It turns clear and colorless. What you end up having it's not gone because we're not, greater than the universe. What it is, it's now sodium ions and chloride ions, completely surrounded by water. So there's water molecules in there. You can't see them, they're invisible. They are completely soluble. Okay? This is what happens when you dissolve a substance. If it was ionic, it will form ions in solution. That would make LiCl and HOH, which is H2O. H2O is a liquid. Lithium chloride is an ionic compound. Is it going to be an S or an AQ? AQ. Okay. So will we see this? What does water look like?
Clear.
Clear? Does it have a color? If it's brown, you need to run your tap a little bit. It's full of rust. Colorless. All acids are clear and colorless. All bases are clear and colorless. So you don't actually see a change here. But what is HClAQ? What's the name of that first compound? Hydrochloric acid. What is the name of the second compound? Give you a hint, it starts with lithium. What is it? Hydroxide. We've got an acid and a base. So this is one of the ones where you see a change in pH. This has a low pH. So it's going to be around 2. This has a high pH. This is going to be around 12 to 14. This will have a pH of 7. So this reaction does go. This is an acid-base neutralization reaction. When you have an acid plus a base, you will always make a salt and water. And the salt is another name for an ionic compound.